this lecture, we will go over Python's NumPy library. NumPy stands for Numerical Python. This library has a number of built-in functions for linear algebra and random number generation. NumPy is often used with other libraries such as Scientific Python and Matplotlib as a replacement to MATLAB. So why to use NumPy? The obvious reason it's fast, because these linear algebra operations are based on algorithms that need to be implemented with care. Other than that, the performance would be slow. Also, this library supports a number of mathematical operations which are not available with lists. And this library is often used by other libraries internally, which makes it an important one. Arrays make the core of the NumPy library, and an array is an n-dimensional array type. And in order to make array operations fast, these ND arrays have fixed size and contain elements of the same data type. So why it's important to have a fixed data size? Because if the array is resizable, then it can be stored in different places of the memory, and there will be some indirections, which you don't want to have if you're doing a larger scale linear algebra operations. So here's an example. Import NumPy as NP. Then we call array to create an array. So here's we have a one-dimensional array. And in the second operation, we have a two-dimensional array. So the content of the argument, looks like a normal list or list of lists. And again, here's how to initialize a NumPy array. First, you need an object that returns an array, and you need to specify the type. So if you don't specify the type, then the default is going to be float. If you specify the type, as in this example, as complex, you would get this data type. Remember that J means that this is a complex value. Sometimes it's useful to be able to give an initial value to an array like zeros and ones, because these things are used in linear algebra operations. So if you don't specify how you want to initialize it, it's going to have rubbish or arbitrary values. If you'd like to create an array and initialize it with zeros or initialize it with ones, they already have an operation for this purpose. Zeros would fill the array with 0 values, and 1 would fill the array with the value of ones. And remember that the data type of the default type is floating point, so that's why we see this floating point after the number. NumPy.aRange is exactly what you think it is. It's initializing a NumPy array with a sequence that is generated using the range operation. It has this form: start, stop, step, and data type. In this example, we initialize a NumPy array with 10, 12, 14, 16, and 18 with integer data type. Here are a few NumPy array attributes. ndim, number of dimensions, also called the rank of the array. The shape is a tuple of integers indicating the size of the array in each dimension. So it will be a tuple of n and m in the case of a matrix. And the length of this tuple is the rank, or the ndim. The size, the total number of elements in the array. And reshape, it's an operation that reshapes the array. It doesn't transpose it, it's just change the structure, the number of rows and columns, and redistribute the values. So in this example, we have a two-dimensional array with ndim2 and shape 2 and 3. Then we reshaped it to 3 and 2, so we have 3 rows and 2 columns. So the values are redistributed. And the number of dimensions is 2, and the shape is 3, 2. And here's a reshape example. We have an array with 24 elements, and the dimension is 1. Then we reshape it to 2, 4, 3 array. And see, because it's this is like 3-dimensional, so the first index specifies this is what goes in 1 dimension, and this is what goes in the 2nd dimension. And this is 4 by 3 and 4 by 3. And you see that here we get from 0 to 11, and on the 2nd dimension you get from 12 to 24. For the following slides, we will go over NumPy indexing and slicing, and in spirit, NumPy indexing and slicing similar to the work we did for the sequences, but with taking the number of dimensions into consideration. So here's an example for the 1-dimensional case. We created an array, then we created a slice. So a slice, in this case, you can think about it as the range because it's 1-dimensional array. So you want from 2 to 7 and with 2 steps, so you get 2, 4, 6, which is similar to the range of 272. Here's an example, but with 2-dimensional array. So first we print the array, or the 2-dimensional array. And then we want to access 2 and 1, which is 0, 1, 2, and 1, which is 5. So if we want to slice from index 1, so from row 1 all the way to the end, you get the content of the 2nd and the 3rd rows. Ellipses refers to slicing multidimensional NumPy arrays. And here's an example. I highly encourage you to go and try these examples by yourself on Python. And not that on the right-hand side, the output is not always aligned with the print statements. So first, we create a 2-dimensional array and print this array. And if you are interested in the 2nd row, you can go directly and type my array of 1. And this is a slicing expression, so that if you want 0, 1 up to 2, 2 is not included, then you write this expression. So ellipses, expression that will help us to get the items on the 2nd column, which is the 2, 4, and 5. And this is equivalent to this slicing expression. Maybe you will find this more intuitive. Maybe you can just stick with slicing. Also, this expression, ellipses expression, gives the items in the 2nd row. And if you want to use an expression, a slicing expression, 1 then colon, that means you want 1 and 2 and so on. So now we want to slice all the items from column 1 and onwards. You can use this ellipses expression. So this is for column 1, and this column just to do it for the rest of the columns. So if we don't have this column, then you will only get 2, 4, and 5. Here's another indexing and slicing example that is a little bit intense. So here is a matrix, 0, 1, 2, 3, and 4. So if you want to print my array of 2 and 3, this is easy. 2 and 3, 23. Here, the rows 1, 2, 3, which means those 2 rows. And the 2nd column of my array. So the 2nd column of these rows is 11 and 21. Okay, each row in the second column of my array. So which means like I want the second column. 1, 11, 21, 31, and 41. Each column in the second and third row of my array, so these are the second and the third rows, hope you still see them, are going to be returned by this expression. And the last row is equivalent to -1. My array of -1 would give you this. The last slide in this category is the Boolean indexing. So what is Boolean indexing? We have a Boolean condition. If this condition is met, then we want a true instead of the entry. And if it doesn't meet this condition, then we want false. So this is an array. And then we create this Boolean array based on my array greater than 5. So for all elements that are greater than 5, we get true, and the ones that are not, we get false. Now we will print the items greater than 5. So if you want to print my array of this bools, then you get the items that satisfy this condition. We will go over NumPy's basic operations. Arithmetic operations in NumPy are applied element-wise, and the operation returns a new array. Let's walk through this simple example. Array A has the content of 20, 30, 40, and 50, and array B is initialized using a range, and if we print B, you get 0, 1, 2, 3. Suppose we want to subtract A minus B, you get 20. 20 minus 0 is 20, 30 minus 1 is 29, and so on. And then if we want to compute the power of the elements in array B, just we do the double star. And 10 multiplied by np.sign of the array A is this result, and feel free to verify it. And array A less than 35 gives the Boolean of this array, which is true, true, false, false. In-place operations are those operations that work directly on the array or the data structure. They do not create a new array and return it. Let's take a look at this example. First, we create an array of ones, and note that the type is integer here. Then we create another random array with the same dimensions. So we add 3 to the content of A, and we get all 3s. And also here we print B. So remember that the random generates a random value between 0 and 1 exclusive, and it's of type float. So now we try to add the content of A to B. So A is integer and B is floating point, so this is fine. But if you want to do the opposite, we get an error, a type error, because A is integer, but we can't add something floating point to it because we don't know how to convert. So that's the meaning of this error. Cannot cast U function or universal function add output from the type floating point to integer. Unary operators or operations are those that are performed on the whole array, such as sum, minimum, maximum. And here's an example, a randomly generated array, and then sum, min, and max are computed. Sometimes we like to do sum of a column, sum of a row, or finding the minimum or maximum of a row or column. So these operations are very useful. So first, in this example, we create this matrix. Then we want to sum each column. That means axis 0. If you want to do an operation on the row, then axis would be 1. And there is something called cumulative sum that you want to add. So 0, then 1 and 0 is 1, and then 2 plus 1 plus 0 is 3, and 3 plus 2 plus 1 is 6. So now you get what is it, this cumulative sum. And the last operation in this set is universal functions like exponent, square root, and others can be performed on arrays, and just you call them. For the following slides, we are going to go over some of NumPy's array manipulation operations that modify the content of the array, such as transpose, insert, delete, append, and so on. So transpose means that we want to make the rows columns, and is performed using the .t. Concatenation means to join two or more arrays, but there are some restrictions. We need to preserve the shape and specify the axis, whether it's axis 0, 1, 2, and so on. So we have two matrices. You want to join them along axis 0, then we get them as rows here. And if we want to join them along axis 1, then we get 2 more columns. Append means to add at the end, and in this context we need to specify the axis, but if we don't specify the axis, it's going to be flattened and added. So here we want to add 7, 8, 9, and then it got to the end because we didn't specify the axis. Here we specify the axis, then we get it along axis 0 or at axis 1. Insert, we want to insert values at a particular location in the array. So in this example, if you don't specify the axis, it's going to be flattened. Here you only specify the position. So the third position would be after the 3. But if you specify the position, then you would get it where you want it to be. So axis 0 would be a row, and axis 1 would be a column. Delete is what you expected to be, is deleting content from the array. And interestingly, I think this syntax this is the first time we use it, I believe. Here we call arrange and reshape, but then if you do plus 10, then it's like you add 10 to the content. So if you want to delete 5, but you don't specify the axis, then it's going to flatten it and delete whatever was at position 5, 0, 1, 2, 3, 4, 5. So it deleted the 15. And here you specify that the position and the axis, then you get your column, the column at position 1 to be deleted. And there are some useful functions like round, floor, and ceil that you can call and apply on NumPy arrays. The ceil, it's rounding up, the floor rounding down, the normal round function that if it's 0.5 and up, it gets rounded. But here is something interesting happen with the decimals. So at the first, we just do the normal rounding. So 1, 6, 1, 2, 3, 123, 1, and 26. So if you want to round to 1 decimal place here, just we have 1 decimal place, and 55 become 0.6, and this becomes 0.6, and this becomes 25.5. Interestingly, what does it mean to do -1? -1 is like tens. So 1 is closer to 0. 6 or 5 will go to the 10. 123 will go down to 120. 0.6 will go to 0, and 25.5, it's going to go to 30.
The last topic of this lecture is statistical functions.
In order to perform the median on array, we call the median operation, and median is the middle value, and you can apply it on the whole array or on a particular axis, whether it's axis 0 and axis 1. Similarly, mean and standard deviation are operations that available in NumPy and can be called based on the whole array or along a particular axis. So with that, I conclude this lecture. Thank you and good luck.